Good evening, sir.
Good evening, Gupta. Good evening, everyone. Good evening, Rachit.
Good evening, sir.
Good evening. Pranav, good evening.
Good evening, sir.
Good
Okay,
evening.
I think it's audible to everyone.
Yes, sir.
Okay, so in last class, we were doing our chapter 1 from chemistry. We were quickly revising chapter 1, matter around us or matter in our surroundings, class 9. So we had seen that matter is made up of a number of particles, and those particles they have spaces in between them. So matter is made up of tiny particles. Those tiny particles they have space between them. Got it? And the particles of matter they are continuously moving. They are not stationary. Got it? So the particles of matter they are continuously moving. These were the two things which we discussed in the last class. I hope you are able to recall or remember that. Then, so the particles of matter have space between them. Particles of matter, they are continuously moving. And the particles of matter, they attract each other. That is why they are holding every particle together. Okay. So particles of matter, they attract each other. Okay. Suppose I take an iron nail and I try to hammer it. Okay. So the iron nail does not break into pieces. It changes its shape. Whereas if I hammer a piece of chalk, it breaks into pieces. Okay. If I take a rubber band and hammer it, so it also changes its shape. So it means that the particles in iron nail they are held together with the strong forces. So that is why they do not break. Whereas pieces of chalk, a chalk is broken into tiny pieces, which means that the chalk itself is held together. The particles of chalk they are held together with forces which are very weak. So we can say that the particles of matter they attract each other and they hold each other with forces of attraction. Got it? So
Yes,
is this
sir.
clear to everyone? The three properties which we have studied up to now?
Yes, sir.
Okay, so the three properties which we have studied that the first property is
Sir, particles of matter, matter is
hmm,
made up of small part. Yeah.
hmm,
Particles of matter attract each other.
hmm,
Particles
okay,
of matter, uh,
okay. So first of all,
have
particles of
spaces.
matter,
Yeah, particles of matter have spaces between them.
yeah, have space between them.
Particles
Then
of
we
matter
can
have a
say
strong force of attraction.
yes, particles of matter
And
have
particles of matter are in a state of continuous movement.
okay. So particles of matter have strong forces of attraction.
And particles of matter are continuously moving.
Okay. Also have particles of matter are continuously moving. So these are the two things which we discussed in the last class.
Yes, sir.
Okay, so the three things, particles of matter, they have space between them, which can be proved by dissolution of sugar in water. If you try to dissolve sugar in water,
Yes, sir.
so the volume of the solution does not increase. Rather, the sugar occupies all the interstitial spaces between the particles. So this shows that the particles of matter, they have space between them. The second thing we know, particles have strong forces of attraction, which can be shown by hammering different objects. Like we can hammer iron object, iron nail, we can hammer a chalk piece. So we see that if I hammer a chalk piece, it breaks into pieces. But if I hammer an iron nail,
Then it
so
won't break because it has strong force of attraction. It's particles.
no, if something breaks, so the forces of attraction are not that strong.
Weak, sir, it's weak.
It's weak, but if it is still held together, that means the forces are strong. For example, for an iron nail. Okay. The next one, we have particles. They are continuously moving, which we observe in the case of uh, like we observed with the case of KMNO, for example, that is potassium permanganate. When we dissolve, if you take a liquid and just put a small drop of ink at the top, so the ink will spread throughout the solution. It means that the particles of matter, they are continuously moving. So these are the three properties which we should be able to remember. Now, we do states of matter. So matter exists in three states around us. So what are the states of matter that we have seen? We see that matter occurs in three states, which we know as
The
a solid,
solids, liquids, and gases.
okay, solid, liquid, and gas. So solids, they are categorized. Solids, they are identified as the substances which have a definite shape and size. Their
Definite
shape
shape
and
and
size
size,
is
sir.
fixed.
Whereas liquids and gases take up the shape of the container in which they're kept in.
So this is a definite shape and size. Solids have a definite shape and size. Liquids, they have,
The ability to flow.
okay, liquids, they have,
Sir, and they take up the shape of the container, right?
okay, yeah, just will come to the shape. Liquids, they have a definite size, but not shape.
Shape. They take up the shape of the container in which they're kept in.
Yeah, so they have the definite size, but not shape. Definite size means volume. So they have
Yeah,
a
they have
definite
definite
volume,
volume. Yeah.
yeah, but no definite shape. So their shape is not definite. They can
Definite.
occupy any shape. All right. So if they are kept in the in whatever container they are kept in, they
So they
occupy
take
that.
up the shape of that container due to their size.
Yes. Now gases they do not have a
Have a
definite shape
definite shape,
as
but
no definite shape, no
no
definite size.
definite size
Okay, nothing is fixed for them. So gases they have no definite shape,
and no definite
no
size.
definite size. Okay.
Sir, and
So
also,
hmm,
they both liquids and gases can flow, right?
yeah. So gases have no definite shape and
And no
no
definite
definite
size.
size. So they will occupy the complete space available to them. Whatever space is available to the gases, they will occupy the complete space which is available to them. Now, why this property? They will try to explain the differences between the properties of solids, liquids, and gases. Okay. Why this difference is there? That why the solids have a definite shape and size, while liquids do not have a definite shape and size, whereas gases do not have a definite shape and size as well. So for the solids, the particles of matter, they are held with the strong forces of
Yes, sir.
electrostatic. They are held together with the strong electrostatic forces of attraction, and therefore, see,
Sir, is it because of this property that an iron almirah is solid at room temperature?
yeah,
Okay, sir.
no, if you have the question like, why should we call the iron almirah to be solid? It's because it has a definite shape and size.
So that's what, yeah.
Okay, it has a definite shape and size, so that is why we call it as a solid.
Okay,
Now
sir.
see here, this one, a solid, it has all the molecules which are
Sir,
fixed. Okay.
there's no space between them.
Yeah, no, there is a space. Even between it, even in the solids also there is a space between
But
them.
they're held with strong forces of attraction.
Yeah, so the position of the molecules is almost fixed. They are just vibrating about their mean position.
Yes, sir.
Whereas for the liquids, the particles are in continuous motion. The particles are continuously moving. They can slide over each other. Okay. Whereas the particles of a gas, they are also continuously moving.
So they move at random. They move randomly at high speeds, no? The
Yeah,
particle in gases.
they move randomly at high speeds. Okay. So also the intermolecular forces of attraction between the particles in gases is very
Is strong in solids, moderate in liquids, but
less in gases.
less in solids.
Okay. In gases the amount of forces between the molecules is very less. So therefore the molecules are almost free to move from one place to another. Okay, so that's why the molecules move almost freely from one place to another. Whereas in liquids also the particles are just sliding over each other.
Yes, sir.
Okay, they are not freely, but they are sliding. They are moving away from each other. So that's the case of the liquids. Okay, so you have the solids, liquids, and the gases. These three characteristics they can prove or they can show how the properties of each of them is different from each other. All right. Now we see here why. So this property leads to the change of state. How can a change of state occur? So
Sir,
let's
due
see.
to change in temperature and change in pressure.
Yeah. So how will it occur the change of state? Let's see. As we know, that in a solid, the particles are tightly packed. In a liquid, the particles are loosely packed. Whereas in the gases, the particles are free to move. So if I see these cases, I can make one of the state getting converted to the other state. I can make the solids getting converted to the liquid state by supplying some amount of heat energy. If here I supply some amount of heat energy uh, to this solid, so this solid will get converted to liquid as the particles will gain some amount of kinetic energy.
Yes,
When
sir.
I am supplying some energy, the particles will gain some energy and therefore their random motion will increase, which will make them unbound from their forces of attraction. Okay. So the forces of attraction which are currently holding them strongly at their positions, the forces will become weak due to the gain of the kinetic energy. Hello.
Yes, sir.
All right. So you have heat. If you supply the amount of heat to the solids, the solid gets converted to the liquid state. How it happens? The particles gain. So if you supply some amount of heat energy to the solids get converted to the liquid state. As the particles gain energy, so they become liquid. Now, if you apply more amount of energy to them, if I supply more amount of heat energy to them, so they get converted to the gaseous state. Thus, by increasing their speeds, the speed of the each of the particle will increase. Got it?
Yes, sir.
Okay. Now, what role does pressure play? Is there any role of pressure? Yes, who
Sir,
can think of?
more.
Niharika, is there any role of pressure? This is the role of heat and temperature that we have understood. That here, if I'm supplying some amount of heat energy to the solids will get converted to the liquid state as the particles will gain energy. So they will get converted to the liquid state. Okay. When
Sir,
I supply some
sir.
amount, just when I supply some amount of heat energy to the liquid, it gets converted to the gaseous state. Again, the energy of the molecules increases. If I want to go from the gaseous state to the liquid state, so I will be absorbing some amount of heat. If I take away some amount of heat from here, Suppose if I take away heat from this, I'm removing heat from this. So the motion of the particles will decrease. As a result, they will become less random and they will get converted to the liquid state. Yes. And from the liquid state, we can take out some amount of heat. Okay, here we can take out some amount of heat. If some amount of heat is taken up from this liquid state, so this will still decrease the kinetic energy of the molecules, and therefore the particles, they will become more fixed and formed at their positions, changing them to the solid state. So by providing heat, we can change from solid to liquid to gas, and by taking out heat from the substance, we can convert it from gaseous to liquid and from liquid to solid. So our refrigerator works in the same way. The refrigerator takes away heat from the liquid and converts it to solid. Is this understood by everyone?
Yes, sir.
Yes, sir.
Now
Yes,
a similar role
Yes, sir.
is played by pressure also. Consider here we have taken a gas. Okay, in a container I have taken a gas. So in this container I have a piston. A piston is the movable part. So here I have a piston. Okay, so here we have a piston, and there are a number of molecules which are there. You have some air molecules which are here. So these are some of the gas molecules which are there. As we know that the gas molecules, they are more random or more free to move. Now, if I increase pressure over here, if I increase pressure, so the volume will decrease. Yes. If I increase the pressure, will the volume decrease or increase?
They'll decrease.
Yeah, the
The
volume
decrease.
will decrease. So the space between the molecules will decrease.
Yes, sir.
Yes, sir.
So the space between the molecules will decrease. As a result, the molecules will be, so suppose I compress it like this. Okay, if I compress it, the space between the molecules will decrease, and this will decrease their motion.
Yes, sir.
Okay, if the space between them decreases, so this will decrease their motion. Now you can see that they have less space for their motion, and therefore I can say that the substance will get converted to the liquid state. Will it get converted to liquid state?
Yes, sir.
Okay, so gases can be converted to liquid state by another method, that is by increasing the pressure. If you increase the pressure, so gases will get converted to liquid state. Okay, and this we call as the compression. We are compressing the gas. So by applying the compression, we are able to change the gaseous state to liquid state. Got it? Is this clear?
Yes, sir.
And similarly is the effect with the liquids also. Okay, liquids can also be changed to solids again in the same way. But alone, pressure alone cannot work. We also have to include the temperature factor. Got it?
Yes, sir.
Okay.
Sir,
So,
sir, by decreasing the pressure and increasing the temperature, can we also convert solid to gas, like solid to liquid to gas?
repeat your question.
Sir, by decreasing the pressure, can we also
Increasing the
convert?
pressure. Okay, your first point is increasing the pressure, and what's the second thing?
Sir, by decreasing the pressure.
Decreasing the pressure or decreasing the temperature?
Temperature.
Okay, by the change of pressure, you can bring about a change of state. Okay, if you are increasing the pressure, it will be changing from gaseous to the liquid and liquid to solid. Okay. If you are decreasing the pressure, so it will be changing from solid to liquid and liquid to gas.
So, sir, uh,
Hmm.
pressure changes the state of the matter.
Yeah, pressure can change the state of matter. As the temperature can change, the same way pressure can also change.
Okay.
Okay. So the change of state can be brought about by two methods, either by changing the pressure or by changing the temperature. Got it? All right.
Yes, sir.
So this was about the change of state. Then the next is evaporation. Okay. So what is evaporation?
Sir, evaporation.
Hmm.
So the process of conversion of liquid into vapor state
Hmm.
at any temperature is known as evaporation below its boiling point.
Okay, okay. See. So see how it happens. So first of all, we see the change of all the three states. A solid can be changed to directly to the gaseous state, which we call as sublimation, and a gas can be changed directly to the solid state also, which we call as deposition. Okay, a solid changing to gaseous state is
Yes.
sublimation, and a gas changing to solid state is called as deposition. Similarly, a solid can be changed to the liquid state, which we call as fusion, or we also call it as liquefaction, and the liquid can be changed to solid state, which we call as solidification. So ice changing to water is fusion, and water changing to ice is solidification. A liquid can change to gaseous state, which we call as vaporization, and a gas can change back to the liquid state, which we call as condensation. Got it?
Got it, sir.
Okay. So these are the three things. Now, depending on this, the change of state, we will now define what is vaporization. So let's try to understand what is vaporization. Vaporization.
Sir, it is a change of matter from liquid state to gaseous state at specific conditions of temperature and pressure.
Okay, it is the process of change of state from
Liquid
liquid to
to gaseous state or vapor state.
okay, liquid to gaseous state
Under
at
certain
any
conditions of
temperature.
temperature and pressure.
At
Pressure, no?
any temperature and pressure.
Yes, sir.
Okay. So the process will occur at any temperature and pressure. Now see how it happens and what it has to do. So it is first of all, it is a surface phenomena. Okay, it's not
Yes,
a
sir.
bulk phenomena, it is a surface phenomena. Consider here we have a container, and in this container we have a liquid. So here our container has liquid, and we can see this liquid to be in a number of molecules. What we are looking is that there are a number of molecules of which this liquid is made up of. The particles have some spaces between them so that they can move on freely. They can move on or slide over each other. Now, these are the molecules which are located at the top, and these are the molecules which are located at the bottom. The molecules at the top, they possess more energy as compared with the molecules at the bottom. So, the molecules at the top, they are bonded, they are attracted towards the molecules which are inside. These two molecules, they are having some forces of attraction. These molecules, they are having some forces of attraction with each other, which is holding the top layer of molecules with this. Now, if the top layer of molecules gain some amount of energy so that they will be able to break the bonds of attraction with the bottom ones, So they will be freed from the surface and they will fly up. They will move away from the liquid in the form of gaseous state. So for that, they need some energy. Okay. So where is that energy obtained from? The energy which is okay. So the
Yes, sir.
energy which is required over here for the top layer of the molecules, that energy is obtained from surroundings or from the neighboring molecules. They absorb some energy from the neighboring molecules or they absorb energy from the surroundings. Okay. So when they absorb energy from the surrounding or by the neighboring molecules, when they gain that amount of energy, they are able to break up the bonds with the bottom one and hence move away from the surface in the form of gaseous state or in the form of free atom, free molecules. Got it? So more and more of the vaporization will occur. You will get more amount of vaporization to be occurring when more surface will be exposed. Greater the surface area of the liquid, more will be the amount of vaporization that will occur. Okay. Also, so vaporization we can say here, vaporization is a surface phenomena or vapor formation is a surface phenomena. Right. And it is dependent on is a surface phenomena and is dependent on it depends upon the area of the fluid that is exposed, and it is also dependent on temperature. Higher the temperature, more will be the rate of evaporation. The lesser the temperature, lesser will be the rate of evaporation. Got it?
Yes, sir.
Okay. Now, as we increase the temperature, the evaporation, the rate of evaporation also increases. Okay. More and more vapors are formed. So, a state comes when the vaporization, it becomes maximum, beyond which the rate of the formation of the vapor cannot be increased. So, that state when the vaporization is maximum, we call it as maximum vaporization and we call it that to be the boiling point. At the boiling point, the pressure exerted by the vapors and the pressure exerted by the atmosphere is the same. So you can say the boiling point now try to understand what is boiling point here. It is the temperature okay, the temperature at which vapor pressure is equal to the atmospheric pressure equals atmospheric pressure. So suppose here the atmospheric pressure is somewhere as let's say PA. As if I increase the temperature, more and more vapors are formed and those vapors they exert a pressure on the fluid. As vapors are also gases, so they also exert pressure. When they exert a pressure, so if PA or atmospheric pressure is equal to the vapor pressure, the pressure exerted by the vapors, that is the maximum rate of change of state that can occur, beyond which it cannot occur. So that point we call as the boiling point. Got it? If you want to, yes,
Sir, I have a doubt.
yes.
So in vaporization, generally when we, for example, when we take water and we heat it in a pot, then the heat which is supplied from the bottom first reaches the below particles, like the particles which are touching the bowl. So how does the does the heat which are then below particles, they get transferred to the surface particles, or then if the heat is first given to the below particles, then why don't they vaporize first?
Very good. So when you are heating up, when you are heating from the bottom, so the heat is transferred from the bottom to the top by the actual movement of the particles. Okay.
Okay.
Suppose I am heating from the bottom, so this particle gains energy. It moves to the top.
Oh,
Okay. And the particle which is over here, now it has lesser amount of energy, so it's heavier. It will come to the bottom. So on. This cycle continues.
okay,
All
sir.
right. And in this process, if some particles gain sufficient amount of energy, so it evaporates out to the environment.
Okay, sir.
Got it?
Yes, sir.
Okay. So I hope everyone has understood about the boiling point. So
Sir, can you
boiling point is the temperature at which the vapor pressure is equal to the atmospheric pressure. Got it?
Yes, sir.
Okay. So, okay, what do you think? Will the boiling point, how will the boiling point change if the atmospheric pressure is changed? We know that the atmospheric pressure is 10 to the power 5 Pascal. Got it? Our atmospheric pressure is 10 to the power 5 Pascal, which is 1 atmosphere. So atmospheric pressure is written as 1 atmosphere, or it is also equal to 10 to the power 5 Pascal everywhere. What do you think will happen if the atmospheric pressure decreases? Will the boiling point be the same or will it change?
Sir, it will change.
It will change. So what will happen? Will the boiling point increase or decrease?
Sir, it will decrease.
It will decrease, yes. If the atmospheric pressure decreases, the boiling point will decrease.
Yes, sir.
All right. So now there is a question.
sir,
Why should we prefer pressure cooking and not open pan cooking?
sir, in case of pressure cooking, the pressure of the inside the particles, the pressure
Yes, sir.
is lower inside an utensil. But in case of open pot cooking, the pressure is the molecules which are getting heated up are continuously losing their energy with the particles in the atmosphere.
Okay, I'll tell you what happens actually. Why should you prefer pressure cooking and not open pan cooking? Okay. So if you're making an open pan cooking, see what happens. We know that the boiling point of water is 100 degrees Celsius, right? Okay.
Yes,
So
sir.
here we have some water in an open pan. We are trying to boil it. We are trying to cook some food over here. And here we have a pressure cooker. So that we are trying to cook something in this pressure cooker, which is a closed pan. Now, if you are supplying some amount of heat here, so due to that heat, the temperature will increase, and the maximum temperature that the water can reach is the boiling point. Okay, the boiling point of water, which is 100 degrees Celsius. Now, for this one, for the pressure cooker, the temperature inside the pressure cooker, as the pressure is continuously increasing, there is no energy which is skipping out. So all the energy, whatever we are supplying, it remains inside it, and this increases the boiling point. So inside a pressure cooker, the temperatures rise to about 300 to 400 degrees Celsius. Got it?
Got
So
it, sir.
here, where the temperature is about only 100 degrees Celsius, inside a pressure cooker, the temperature is 300 to 400.
300 degrees Celsius. Okay, sir.
So the food is cooked faster in a pressure cooker as compared with an open pan.
Yes, sir.
Okay. So the same thing will happen if you are trying to cook food uh, in an area like in a hilly area where you have a low pressure.
Yes,
So
sir.
in a hilly area where you have a low pressure,
Low
you
pressure.
should you should be using your pressure cooking and not the open pan cooking. As in case of open pan cooking, the water will not even be able to reach a temperature of 100 degrees Celsius, as the boiling point of water will still decrease.
Yes, sir.
Got
Sir,
it?
so it's difficult for the food to cook.
Yeah. So it will take longer for the food to cook. Got it. Okay. So now this concept, you get a number of questions from evaporation like this. This is that evaporation causes cooling effect. So as we know that evaporation can occur at all temperatures. Okay. So you know that evaporation causes cooling effect. So as we know that evaporation is the movement of the upper layer of the particles from a liquid surface by taking out energy from either the bottom particles or from the surface. Okay, from the surroundings. So if any evaporation occurs, so here in a container, if you have any liquid, and suppose we say that evaporation occurs over here. So these are the particles which are there, as the particles can move over each other. Now, the upper layer of particles, they evaporate out. So when they evaporate out, as I told you that to evaporate, they need some amount of energy. And that amount of energy they get from the particles which are at the bottom. The
Yes.
particles which are at the bottom, they provide that amount of energy to the top particles and they evaporate out. As a result, the particles which are at the bottom, their temperature decreases. The particles which are left out, their temperature will decrease, and hence the temperature of the substance will fall down. Are you getting?
Got it, sir. Understood.
Okay. So overall energy of the system is decreasing as the particles are evaporating. The overall energy is decreasing, and therefore there will not be any evaporation that will occur. That means there will be a fall of temperature. And this is the reason when we keep water in earthen pots. Water in earthen pots, like you have heard about matka. Many people, they store water in matka, which are earthen pots. Okay, so it it is cool during the summer season. During the summer season, water is kept over there so that the temperature becomes low. So how it performs? Water is
Well,
stored in earthen pots. Yes.
so earthen pots have some holes in them
Hmm.
through which the water escapes and then um, provides a cooling effect on the surface. Like the water escapes from those holes in the matka or earthen pot and it moves towards the surface of the earthen pot and provides a cooling effect so water remains cool in a matka.
So okay, so how it provides cooling effect? Let's see. There are some particles in this earthen pot. As I said, half part is clear that the particles they get energy and they move out of these tiny pores which are present. So when they move out of the tiny pores, they take out energy. They take out energy from the molecules which are there within the earthen pot. So therefore, the overall energy of the system decreases. Okay. Suppose some particles evaporated out, so they took out some energy from the from the neighboring molecules. So as a result, the molecules which are still there, their energy has decreased. So understood? The similar thing, okay. Can you explain how does cooling effect occur by a desert cooler on a hot dry day? Shravan, Sarvan, can you tell why does a desert cooler? Yeah, Sampath.
Sir, in case of a desert cooler, it is used in hot temperatures, where it contains the cooler contains some water which takes the energy from the surroundings to evaporate, and during the evaporation, those particles cause cooling effect and make the surroundings cool.
All right, very good. All right. So this is correct that on a hot dry day, if you are using a desert cooler, the desert cooler works on spraying some water particles from the cooler into your room. So the water particles which are sprayed into your room, those water particles, they absorb some amount of energy and get converted into their vapor states and therefore move out of your room. So as a result, in this process, they are continuously taking away heat energy of the room and they are moving out. So therefore we can say that there will be more cooling effect caused by a desert cooler on a hot dry day. However, if the weather is not dry, if it's moist, so then it will not cause more cooling. Okay. So any other doubt? Okay. Why does it feel? Why do you feel cool when you put a drop of acetone or a drop of petrol on your hand?
Sir, because the moisture gets evaporated due to the cooling effect on our palms.
The moisture gets evaporated.
Yes, sir. Because the acetone provides a cooling effect when it's put on our moisture, so it evaporates the heat from our skin and provides a cooling effect.
Okay. All right. So obviously, okay. Now the next is conversion of temperature. So to convert degree Celsius temperature to Kelvin, there are different temperature scales which have been used. Okay. You can use a temperature scale, something like this. We know that 0 degree Celsius is the same as 273 Kelvin, and 100 degree Celsius is equal to 373 Kelvin, 373 Kelvin. So therefore, if I have any temperature in degree Celsius, that can be converted to Kelvin by adding 273 to it. So suppose if you have 25 degrees Celsius, which is the room temperature. So at 25 degrees Celsius is the room temperature. If you add 273 to it, so you get 273 added up, you get the temperature to be 298 Kelvin. So your room temperature 25 degrees Celsius is the same as 298 Kelvin. Okay. Anything from degree Celsius which is to be converted to Kelvin, you will get 273 to it. Any temperature which is to be converted from Kelvin to degree Celsius, you need to subtract 273 from it. Got it?
Yes, sir.
Okay. So now see these questions. I think we shall now move on to quickly NCERT questions, and then we'll be doing, after NCERT question, we'll do again some of the hot questions from this chapter. So let's see. Convert the following temperatures to Celsius scale. So quickly tell the answer for the first one.
So 20.
20. All right, it's correct. 20. You just need to subtract 273. For the next one, 470 Kelvin. 470 Kelvin.
So 197.
197. Very good. You just need to subtract 273 everywhere. Okay. Convert the following temperature to Kelvin scale.
So we have to add 273 and 25. So
298.
So I already did the first one, which is 298 Kelvin. Then 373.
So 646.
646.
646. All right. Give reasons for the following observations. Naphthalene balls disappear with time without leaving
Sir,
any solid.
So this is
sir, they
because
are
it's
almost
sublime, because the
Hmm. Yes, Sampath?
Sir, they are sublimable substances, so they undergo sublimation, which they'll convert into directly into gas.
Yes. So naphthalene balls, they are sublimable substances. They get converted directly from solid to the gaseous state. So that is why they disappear with time. We can get the smell of perfume sitting several meters away.
Sir,
so
because
this is
the
the
particles of
diffusion.
So this is
matter.
because due to the fast diffusion of the gas particles, the perfume which is there, it goes through the air.
Hmm. The particles are
Getting
The
diffused.
particle, the particles get diffused in the air, right?
the particles diffuse. Okay. So can we say that the particles are there in continuously motion? That is why
It's
we
like
can,
because of that they
Yes, sir.
get diffused.
yes. Okay, so the particles get diffused directly as they are in continuous motion.
Continuous motion.
Okay. Now the next one. Arrange the following substances in increasing order of forces of attraction between the particles.
Sir, oxygen, water, sugar.
Yes?
Sir, oxygen, water, sugar.
Okay, oxygen, it's a gas, then water, which is liquid, and then sugar. So sugar has the maximum amount of the forces of attraction. What is the physical state of water at 25 degrees Celsius?
So
Liquid,
The
sir.
liquid state.
Liquid state at 0 degrees Celsius?
gaseous state.
The
Both,
gaseous.
both solid and
A solid
both
or
solid.
liquid.
0 degree at 0 degrees
Solid or
Solid
Celsius,
and liquid.
liquid.
Solid
Solid
and
or
liquid.
liquid.
solid or liquid. At 100 degrees Celsius, it's gaseous or
Both
liquid.
Gaseous or
liquid.
Or
liquid.
solid.
Gaseous or liquid, not solid.
Gaseous or liquid.
Okay, give reasons to justify water at room temperature is liquid.
So because water has a tendency to flow.
Yeah, water has a tendency to flow, and
Sir,
at
it
room
has
temperature,
And also
Actually,
and it takes the
actually,
shape of the vessel in which it is kept, and its volume does not change.
sir, it has least forces of attraction.
it is.
Sir, it has least forces of attraction between them. I mean, not least, moderate.
Okay, see, we call water to be liquid at room temperature as at 25 degrees Celsius, water water can easily flow. Okay, it can
at
occupy the complete.
atmospheric temperature.
Hmm? Yes.
Sir, the atmosphere does not support the water to change its state.
Okay. All right. Now, an iron almirah is solid at room temperature
Sir, because it has definite shape and size.
as it has definite shape and size, or you can say that at the melting point of iron is
Melting
very
point
high.
of, yes, sir, yes.
The melting point of iron is very high. That is why an iron almirah is solid at room temperature.
Yes, sir.
Okay. All right. The next one. Uh, why is ice at 273 Kelvin more effective in cooling than water at the same temperature?
Sir, because water at the same temperature has uh, uh, more latent heat. That's why it is not effective in cooling. Whereas ice has least energy, so it is effective in cooling.
See, when ice gets converted to water, both ice and water both are at same temperature, 0 degrees Celsius. So you will say that water at that temperature, it requires
Sir,
just,
because ice absorbs the latent heat of fusion.
yes, because it requires the latent heat of fusion to be converted from one state to the other. Got it? Okay. All right. Bye everyone. We'll see you again in next class and we'll see some other questions. These questions you can just revise through them and we'll
Yes,
see
sir.
some other questions from here.
Thank you, sir. Bye, sir.
Okay, bye.
Thank you, sir.
Thank you, sir.
Goodbye.